Hello good people and welcome back. So in the last video what we did is we ended up that last video working on a generalization of what a long hedge is. And now long hedge was a scenario where we're trying to hedge a future purchase, and therefore we're taking a long position initially, and at the time we want to make the purchase in the future, we are closing out that position by taking a short position, and then we purchase down the line out in the market. Now the generalization of the short hedge is very similar. For the short hedge, what you're doing is you want to sell the asset in the future, and so you're constructing a hedge to lock in the price of that sale, that future sales price. So for the short hedge, you're going to start with the short hedge. And that first short hedge futures price is going to be the F1. Because it's a short hedge, we're going to be essentially selling the underlying at some point in the future, which means that we're going to be receiving F1 for the underlying. Now, at the time of the future sales, what we're going to do is we're going to close out that contract. And in order to close out the contract, we're going to enter into a long position. So the long position is going to come in, and for the long position, we will be essentially purchasing the underlying. So we purchase at F2, that is the futures price of the underlying at that point in time. Now, this closes out our contract. The next step is to actually sell the underlying out in the market. And when we sell the underlying out in the market, we're receiving, that's why we have a positive sign there, S2. So if we rewrite this, we could simply rewrite this as F1 plus S2 minus F2. And if we put the parentheses around S2 minus F2, what we have is F1 plus, remember the definition of basis? A basis is the difference between the spot and the future at the time of the purchase or at the time of the sale in the future. And so that is going to be S2 minus F2, so that's going to be our basis. And that's essentially what we have here. We start with our future price as S2, and then we have the gain on the futures contract as F1 minus F2. That's what we have here. When we put those two together and we rearrange it just the way we did here, we end up with a relationship that says that the outcome of that position is going to be F1, that is the futures price today, right, when the hedge is set up, plus the basis. Now, basis risk really comes from the fact that this future price of the underlying is uncertain. That's really what we're trying to hedge against, because we don't know what the future price of the underlying is going to be. We want to lock in the price today, and the price that we choose to lock in today is F1. And so that future price of the underlying is an issue for us because it's uncertain, and therefore the difference between that future price of the underlying and the futures price at that future time is what we refer to as basis. That's why basis risk, that's what basis risk is all about. Alright, just to recap what we talked about in the earlier video, what we're saying here is that we always want to choose a delivery month that is as close as possible to, but later than, the end of life of the hedge. Remember what that means. What that means is we place the hedge today. If the hedge expires here at some point in the future t, we want to make sure that the purchase or the sale of the underlying happens a little bit before the end of the hedge. Because you don't want to have a period where you are essentially not hedged at all. You also do not want to have to be selling the underlying at the time the hedge is you're closing out the hedge at that point in the future. Now, at that point in the future, there may not be futures contract that are available on the underlying that you are hedging, right? Say you are hedging the price of corn against the variation in the price of corn. If you're doing so, maybe there is no, I know they are, but hypothetically, maybe there no futures contract available for corn at that point in time. So how would you go about dealing with a scenario where you want to hedge on the price of corn and there is no futures contracts on corn? Well, one thing you could do is what we refer to as cross hedging. And cross hedging simply says that you can use a futures contract on another asset that is correlated with the asset that you are looking to hedge. And what does that mean? It means that if we're working with corn, and that's our corn, and it turns out that we cannot hedge against the price of corn, there's no futures contract on corn, but then there's futures contract on wheat, right? There's a futures contract on wheat. We may tap on the correlation between corn and wheat. That says that maybe when corn increases by $10, we know that wheat also increases by $9. Or when corn decreases by $5, wheat decreases by $4. If that is true, that correlation is consistent. If that is true, we may be able to use the futures contract on wheat. And if we're using the futures contract on wheat, the one-on-one relationship that we've been using so far may not exist. By that one-on-one relationship, what I'm saying is we so far have assumed that for each unit of the underlying, we needed to buy or sell one futures. And therefore, we use that one-on-one relationship to find the number of future contracts. Now, when you're cross-hedging, that is when you're using essentially futures contract on an asset that is not the asset that's being hedged, that one-on-one relationship doesn't exist. You have to use a hedge ratio. And that hedge ratio is, what we're going to see in a second, is nothing else but the proportion of the exposure that you should actually hedge on the asset that you want to hedge. So what this says here is that when there is no futures contract on the asset that's being hedged, so there's no futures contract on corn, you can choose the contract whose futures price is most highly correlated with the asset price. So you can choose another contract, say a contract on wheat, if the price of wheat is correlated with the price of corn. Now, if we did this, then you would not only have one component to the basis, you would have two components to the basis. The first component of the basis would be what you know, difference between spot and futures price. But then the second component of the basis would be the difference between the price of corn and the price of wheat. So in this case, the outcome of the hedge would look something like this, where you would start just the same way as you did earlier. You said with F1. Earlier we had F1 plus the basis, right? That was what we had. Now what we're seeing here is that this basis is not simply going to be equal to what did we have? We had S2 minus F2. Now the S2 here is going to be S2 star because that is the price of wheat. That is the basis with respect to wheat, the wheat contract. But then it's also going to include another component to the basis. That second component to the basis will be the difference between the price of corn and the price of wheat, where this value here is the price of wheat and that value here is the price of corn. And remember, the F1 here is the futures price on wheat today. The F2 here is the futures price on wheat at that purchase time or at that sales time in the future. So the basis is going to be split into those two components. Now if you're cross hedging, you remember that you're not going to be able to use the one-on-one relationship. We want to look at the hedge ratio. So what is a hedge ratio? The hedge ratio is nothing else but a proportion of the exposure that should optimally be hedged. And we said that it is a function of the correlation of the asset multiplied by the standard deviation of the the underlying divided by the standard deviation of the futures. And that's what we have here. That is a standard deviation of the change in the underlying, I should say that, the change in the underlying, and the change in the spot price, that is the change in the spot price during the hedging period. And sigma f is the standard deviation of the change in the futures, that is the change in the futures price during the hedging period as well. And rho here is the coefficient of correlation, or the correlation between that change in the underlying and the change in the futures. Now, how do we say this? Well, the way we look at this is by recognizing the fact that the hedge ratio is nothing else but a rate of change, right? It captures how fast it is that the spot price changes when futures price change. Or when, or vice versa, if you use the inverse. And so the way you want to look at it is by making an analogy to the capital asset pricing model. In our capital asset pricing model, and that's the CAPM, I'm going to use a different color here. What you remember is that the return on security is equal to the risk-free plus the beta of that security, return on the market minus risk-free. What beta captures here is a sensitivity to a risk factor, or to a factor. So you could essentially have this as follows. You could say the return on the security minus risk-free is equal to the beta multiplied by the return on the market minus risk-free. And this is why we say that the beta is the slope of the security market line, right? And so what we have here is the following. Beta, which is computed as the covariance between the return on the market and the return on the security divided by the variance of the security, or the variance of the market, can be rewritten as follows. It can be rewritten as a covariance can be expressed as a correlation between the market and the security multiplied by the standard deviation of the market, multiplied by the standard deviation of the security. That's that security I here. I'm going to divide that by the variance of the market. Now we can simplify this further by canceling these standard deviations. So what we have is a beta variable that's equal to the correlation between, so I'm going to use the different color, beta variable that's equal to the correlation between the market and the asset that we are looking at, multiplied by the standard deviation of the asset, the standard deviation of the asset divided by the standard deviation of the market. Now, this looks very much like what we have now is the hedge ratio, and that hedge ratio that we have is equal to the correlation, and that correlation is a correlation between the change in the spot and the change in the futures, multiplied by the standard deviation of a change in the spot, really that should be a change in the spot, divided by the standard deviation of a change in the futures. And so the hedge ratio here would help us adjust our contract, the number of contract, for accounting for the correlation between the spot and the futures market in a way that makes the hedge optimal. Remember that one-on-one doesn't apply. If the one-on-one do not apply, then we have to look at the hedge ratio. And the hedge ratio is nothing else but a sensitivity measure. And so we go back to our slides here. That's what we're looking at. Now let's look at an example of that really quick. Well, let's say we have an airline company, and the airline plans on purchasing 2 million gallons of jet fuel in 1 month. And in order to do that, they want to hedge, and they're going to be hedging using heating oil. Now, remember this: they really want jet fuel, but they're going to be using heating oil. That is, they're going to be doing cross hedging. They're going to be cross hedging. Perhaps they're doing this because there is no futures contract on jet fuel. Okay, so how many contracts do they actually need? And what is a hedge ratio? Remember, when we're cross hedging, we really want to pay attention to that hedge ratio. If we are not cross hedging, usually those movements, the hedge ratio is going to be equal to 1, or is going to be very close to 1. That computing a hedge ratio is perhaps insignificant. But when cross hedging is to be applied, the use of the hedge ratio is important. And so what we're going to do here is we're going to look at historical data, and using historical data, what we're going to do is we're going to compute the standard deviation of futures contract, of change in the futures contract, and we're going to do the standard deviation of a change in the spot during the hedge period. We're also going to compute a correlation, and we're going to compute a hedge ratio as the product of the correlation multiplied by the standard deviation of the change in the spot, that's that value here, divided by the standard deviation of the change in the futures, which is this value here. And that is our correlation. What that gives us is a hedge ratio of 0.78. Now, the 0.78 essentially for us means that we don't quite need one contract for every gallon of jet fuel that we are looking to protect against, right? What we really need is we need 0.78 futures per gallon, and therefore we need to adjust the number of futures that are needed to protect those gallons, the 2 million gallons of jet fuel, and then find the number of contracts accordingly. So the optimal number of contracts is simply going to be equal to what we had earlier was a one-on-one, and to find the number of contracts on a one-on-one, all we did was dividing the quantity that needed to be hedged by the size of the contract. But now, because we need to make that adjustment, we're also going to be multiplying that by the hedge ratio. And so that is going to round up to about 37. Now I want to do a quick example of that in Excel. Let's say this is the data that we have. Let's say this is, I'm going to use a drawing tool here. Let's say this is time 1, time 2, time 3, time 4, time 5, time 6, time 7. Let's see, 7 here, time 8, time 9, time 10. That's what we have. 10 time periods, and we have the change in the spot and the change in the futures. What is a hedge ratio? Well, that hedge ratio, we know, is equal to the correlation between these two multiplied by the standard deviation of the change in the spot divided by the standard deviation of the change in the futures. That's our hedge ratio. So we can compute those in a fairly straightforward way. What I'm going to do next is I'm going to do just that. So I'm going to pull my table, and I'm going to copy, actually I'm going to move this away. So I'm going to copy these values, and I'm going to paste them here, and I'm going to paste transpose. The reason I'm transposing this is so that I can actually plot that relationship. And you remember how we said in the presentation there that the hedge ratio was similar to beta on the security? Well, how about we did that? We do just what we would do to estimate beta. Let's rearrange this. We need to have this on that side, and we can plot this now. So we're going to insert a graph, and we're going to insert, let's say we're inserting a line graph here. Where is it? Let's say scatter graph. Let's do a scatter. If we insert a scatter, on the x-axis we have a change in the futures. On the y-axis we have the change in the spot. And that is that relationship there. Now, what is the equation that the equation of this line, that regression line? So if we plot that, that regression line is going to give us something like this. And we said in that case that the hedge ratio was this value. So 0.9456. That would be our hedge ratio, because in this case that would be the beta of our security. That would be our hedge ratio. Now, how do we verify that this value is true? Well, we said that it is the correlation, and so we can find the correlation, and that correlation is equal to correl, and the correlation between these two values there we go. That's our correlation coefficient between the two. So we have the first variable. Next, we need the standard deviation of the change in the spot. So spot is that standard deviation, and that is standard deviation of the change in the spot. Let's use that. That's our standard deviation of change in the spot. How about the standard deviation in the change in the futures? That's that value here. So futures is def, and that's equal to standard deviation of the futures, and that futures is this. Close that, enter. We have all we need. So the hedge ratio should be equal to our correlation, which is that value, multiplied by the standard deviation of change in spot, that's this value, divided by the standard deviation of change in futures, that's this value, and enter. And that's about what we get. Our hedge ratio. And so our hedge ratio is exactly going to be equal to what we obtained using our regression. So you can tell now that the hedge ratio is indeed the result of a regression analysis, just like beta for a security is the result of our regression analysis. All right, so let's go back to our notes here, and we understand now how to obtain the hedge ratio. We understand also how it is that we go from the hedge ratio, having the hedge ratio, to finding the optimal number of contracts. So we need to clarify that relationship with what comes as an equation that captures the change, the optimal contract computation. And so our optimal contract, or the number of contracts, is going to be equal to our hedge ratio multiplied by the position, so say quantity to be hedged, divided by the quantity of our forward or futures price, so QF. So number of contract is going to be hedge ratio multiplied by the quantity to be hedged divided by the quantity of a futures contract, or the futures contract size. That will be our hedge ratio. Now, so far we've been talking about futures contract, but we've completely ignored one of the essential or very important features of a futures contract. The very important features of a feature of the futures contract that we essentially ignored is the mark-to-market, or the daily settlement. Now, if we are settling daily, what we are going to ultimately have to do is making an adjustment to our optimal hedge ratio to reflect the daily settlement in the futures contract. ignoring that daily settlement works for forward, because forwards are not settled daily. So if we are consistent with the idea of working with futures contract, then we need to adjust that optimal hedge ratio to reflect that daily settlement. And to do that is fairly simple. All you have to do is to essentially use a correlation for the daily changes, use a daily standard deviation, and use a daily standard deviation of futures. So daily standard deviation of the spot and daily standard deviation of the futures. And here we have a correlation using the daily changes. That corrects our optimal hedge ratio to account for those daily settlements. Now, early on, we didn't have to worry about that, but remember the definition of our hedge ratio earlier. The definition of our hedge ratio earlier, if we can go back to that slide, the definition of our hedge ratio is a change in the spot price during the hedging period. This hedging period is not 1 day. When we correct that for a change in the spot price for the day, we are effectively working with the futures contract, and we are effectively accounting for that daily settlement. All right, a quick reminder, how do we find the futures, the number of contracts? Well, our optimal number of contracts we saw earlier is simply going to be equal to the hedge ratio multiplied by the quantity to be hedged, and divide that by the quantity of the futures contract, or the size of the futures contract. So QA is going to be the position to be hedged, and that's the quantity, and QF is going to be the size of the futures contract. That's the quantity of, or the size of the futures contract. Now we could also express this in terms of value, and in doing so we would essentially be accounting for the daily settlement of futures, and that would be what we have here. When we account for daily settlement of futures, we would be using that adjusted hedge ratio, and remember that adjusted hedge ratio uses the daily correlation as well as the daily standard deviations, and we would account for the use the values of the futures position as well as the values of the position being hedged. Okay, so so far our discussion has focused on essentially hedging say a commodity contract, right? Or how would you go about doing that for a portfolio of equity, or an equity portfolio? So we would let's use an example for that. That example would be something like this. Let's say today is January, and we currently own a portfolio, and our portfolio has a value, it's called as V0 of let's say 5 million. That is the value of our portfolio. Now, we believe somehow that market conditions are going to be poor in the next couple of months. Let's say 3 months. Market conditions are going to be poor in the next 3 months. We're going to have February, March, and April. Right? So we are the end of January, so that's going to be February here. We're going to have March and beginning of April. That just give us 3 months. Now, we believe that the price of the underlying, or the value of our equity portfolio, this is a portfolio of assets. That portfolio of assets is a combination, is a basket of securities. So it's going to be a series of securities in here. The value of this portfolio is equal to 5 million. We believe that somehow market conditions are going to be poor, so we want to hedge against a downward movement in the value of our portfolio. Now, one thing that we can do is essentially just sell the entire portfolio altogether. But then if we did that, we would have to sell every single security within our portfolio, and selling every single security within our portfolio would create a ton of transaction cost. And so maybe we don't want to do that just yet. How about we may also believe that the negative effect or the negative market conditions is only going to last for 3 months. So after the 3 months here, market conditions are going to be good. So we want to still hold our portfolio at this point so that we can take advantage of positive market conditions after the poor market conditions. So the poor market condition is going to be over this period. So this is going to be poor. And then after that, we expect a good market condition here. And so the question becomes, how do you deal with this? How do you address this? Well, you could hedge this portfolio by engaging in the futures market and essentially shorting the index. And shorting the index will mean understanding what the index futures is like. The idea here is that because this portfolio is unique, it's yours, you really don't have a futures contract on a portfolio, on this specific portfolio that you hold. However, there are index futures on the market that you could use. So in effect, you would be cross-hedging. And you'll be cross-hedging using futures, index futures. Now, let's put together some data with respect to the index futures. The data that we would have with respect to the index future is that the price of the index, let's call that I0 today. The price of the index today, let's call that I0, is going to be equal to 1,000. The futures price of the index in 3 months, 3 months futures price of the index is going to be equal to 1,010. The contract size is going to be equal to 250. And we also told that the portfolio beta that we have has a beta of 1.5. Our portfolio has a beta of 1.5. And we also told that the index pays dividends, so the dividend yield is equal to 1% per year. And finally, the interest rate, the risk-free rate of return, is going to be equal to 4% per year. How would you put together this hedge? Well, in order to put together this hedge, the first thing you would do is you own the portfolio, which means that you may want to be selling it. The hedge is in effect protecting against that future sales of the portfolio. So because you're anticipating selling in the open market, in the physical market, you want to take a short position in the index. So one, we know is going to be a short index futures. And two, we know that we're going to be cross-hedging. And because we're cross-hedging, we know that we need to find the optimal hedge ratio. And it is that optimal hedge ratio that's going to tell us the number of contracts that we need to get. So let's find that hedge ratio first. Well, the hedge ratio is a function of the correlation. Remember what we had earlier. So let's go back to the slides that we have earlier. And our hedge ratio here was a function of the correlation. Let's go back to the slide here. Was a function of the correlation between the asset, the change in the value of the asset and the change in the value of the future, multiplied by the standard deviation of the asset and the standard deviation of the futures. Now, it turns out that we could express the number of contracts for our hedge in equity index, using the equity index, using the beta of the portfolio that we're hedging. And that beta is essentially what we're given here. So that hedge ratio is going to be equal to the beta multiplied by the value of our portfolio, that is the value of the portfolio that we're hedging, divided by the value of the futures contract. And the value of that futures contract is going to be equal to our index futures price. So that's going to be our index futures price, F1, multiplied by the contract size. The contract size is 250, so we're going to multiply that by 250. So what would that give us? That would give us the beta of 1.5, so 1.5 multiplied by the value of our portfolio, that's 5 million, divided by the futures price, and that futures price is 1010, so it's going to be 1010 multiplied by the contract size. That contract size is going to be equal to 250. Now remember that what we're doing here is essentially the hedge ratio is equal to the beta value of the portfolio, and that's what we refer to as A here, and that's the value of the forward of futures price. So that value of futures is the value of 1 multiplied by the contract size. That's in effect what we're doing. Now if we do the math here, what you're going to find is that where's my financial calculator? There we go. We're going to find that we need 5 million 1 2 3 divide that by 1010, divide that again by 250 equal, and then we multiply that by 1.5. That's about 29.7, so approximately 30 contracts. So we're going to need about 30 contracts on this cross hedge. Now we're taking a short index future position, and it's a cross hedge, so we have to find the optimal hedge ratio. Once we obtain the optimal hedge ratio, the question becomes what happens at the time at which we are actually selling the contract, selling down the line. So you remember our short hedge was as follows. If we were to take a short hedge, we would go short the contract, so that's going to be having to sell down the line, so we'll be receiving plus F1, and then at expiration, or at the time we start selling down the line, we will be going long, so that's going to be minus F2, and with this we would still own down the line. We've not sold it yet because this is just closing the contract, and then we would have to sell down the line in the open market at S2. This is the outcome of our hedge. Let's apply this to this scenario, this problem that we have. If we apply this to the problem that we have, we would essentially need to find what F2 is, right? That is the futures price at that point in time in 3 months. And we will also have to find what S2 is, which is the value of our portfolio at that point in time. Let's start with having some additional data about F2 and finding the outcome of our futures position first. And then we're going to add the outcome of find the value of our portfolio at that point in time, and we'll have the outcome of our hedge. So what we're going to start here is with a little more data. The first piece of data that we're going to have is the following. We're going to assume that at some point in the future, so at this point here in the future, what we're going to have is the index price, which is, let's call that I1, is going to be equal to 900. So the index itself went from 1000 to 900. Now from 1000 to 900, what does that mean? It means that the index return over this period of 3 months was 900 minus 1000. I'm just doing the holding period return. So it's going to be 900 minus 1000 divided by 1000. That gives us minus 100 divided by 1000. That's going to be minus 10%. So the index return is going to be negative 10%. So the market itself fell by 10% during that period. Now, we are also told, given information about the futures price at this point. So the futures price at this point, it turns out, F2, the futures price at this point, it turns out, is equal to $902. So that's going to be $902. So we have pretty much all we need. You remember that we wanted to do F1. So our position is going to be plus F1, which is going to be plus, what's F1? The futures price today. That futures price today was 8,010. So that's going to be plus 1,010. And then we're going to subtract the futures at that point in time in the future. That's in 3 months from now. And we told that futures price is going to be 902. So we're going to do minus 902. That closes out our contract. Now, this is for one future. A futures is, now we said we needed 30 contracts, right? So we're going to multiply this by 30. And each contract has 250 futures, so it's going to be multiplied by 250. So ultimately, our position is going to be as follows. We're going to have 1,010 minus 902 equal, that gives us 108. Multiply that by 30 contracts, multiply that by 250. So ultimately, altogether, we're having a profit on our futures contract of about 810,000. This is what our futures contract led to. That would be F1 minus F2. That's that piece. So we're good with this. We're done with this portion. Next question is, what is the value of the portfolio 3 months from today? Now, we have a portfolio today that has a value of 5 million. The value of this portfolio today is going to be equal to, in the future, that's going to be, let's call that V1, the value of the portfolio in the future is going to be equal to the value of the portfolio today multiplied by 1 plus the return on the portfolio. And that return on the portfolio would be the return on the portfolio over 3 months. Now, it is a portfolio of assets, so we can know how we can find the return on the portfolio of assets. The return on the portfolio of assets is equal to the risk-free plus the beta of that portfolio multiplied by the return on the market minus the risk-free. That is our capital asset pricing model. Now, our risk-free, our time period here is 3 months, right? So it's going to be 1, 2, and 3 months. However, we told that the risk-free is for 4% per year. So what is the risk-free for 3 months? The risk-free for 3 months is going to be the 4% divided by 3 months is a quarter, right? So we have 4 quarters, so we divide that by 4. That gives us the 3 months risk-free. To this, we're going to add the beta. Actually, let me use a different color here. I'm just going to use that. So it's going to be 4% divided by 4. And we're dividing by 4 here because in 1 year, we have 12 months. And in 1 year, we have 4 quarters. 1 quarter is 3 months. So if the 4% is for 4 quarters, what is the interest rate for 1 quarter? That will be 1%. And the way you find the 1% is by doing the 4% divided by 4 quarters. So that's what we would have here. To that we add the beta of the portfolio, which is 1.5, multiplied by the return on the market. Now, we had that return on market here. That return on market is what we solved here. That was the 900 minus 1000. Remember, the value of the index in the future was 900. And then the beginning value of the index was 1000. So the holding period return is end value minus beginning value divided by beginning value. That's what gives us it minus 10%. However, the index also earns a dividend yield of 1%, which means that we need to add the dividend yield to that 10%. So what do we have? We're going to have the following. We're going to have minus 10% here, but then we're going to add the dividend yield, and we said that dividend yield is 1%, so we're going to add 1%. Now, the 1% is also a 1% for the year, so we need to divide that by 4 to find the 1% for the quarter. And then we subtract the risk-free. That risk-free, remember, is 4% divided by 4, so that's 4% divided by 4. Now what that gives us is 1% plus 1.5, which is the beta, multiplied by, that is 10%, and this 1% divided by 4 is 0.25%. So that is in effect minus 9.75% minus 1%. And so if we did that, what we would find at the end of the day is that the return on our portfolio, RP, is essentially going to be equal to about 15 point or minus 15.125%. That would be the return of our portfolio. And so the value of our portfolio V1, that's what we are after, the value of our portfolio V1 is going to be equal to V0 multiplied by 1 plus that holding period return for 3 months, which is minus 15.125%. Now, V0 is 5 million, so it's going to be 5 million multiplied by 1 minus 0.15125. Now let's pull our financial calculator and do this. So it's going to be 1 minus 0.15. No, I didn't do that. 1 minus 0.15125 equal, multiply this by 5 million, 5,000,000 equal. So the value of our portfolio after losing 15% is going to be 4,243,750. 4,243,750. So it's going to be 4,243,750. Did I get that right? There we go. 4,243,750. So that's going to be the value of our portfolio in the future. And this value is in effect what we needed here is 2. So altogether, what is the value of our portfolio at the end of the day? Well, the outcome of our hedge is going to be equal to minus, no, it's going to be F1, remember we had F1, plus minus F2 plus S2. And we found out earlier that F1 minus F2, that was this, F1 minus F2, it turns out it was 810,000. That was F1 minus F2, that was for 1 futures, multiplied by 30 for the number of contract, multiplied by 250 for the size of the contract. That gives us 810,000. So that was 810,000. And to that we added the value of our portfolio at the end of the period. So we add $4,243,750. So let's bring back our financial calculator and we add 810,123 to that. So our portfolio at the end of the day is 5,053,750. So we have 5,053,750. So what do we have? We started at 5 million. That was our V0. We ended our portfolio after the hedge. We ended our portfolio at 5,053,750. So the question is, what is the return? What is the actual return after the hedge? So without the hedge, with no hedge, the value of our portfolio V1 would have been 4,243,750. With the hedge, the value of our portfolio is 5,053,750. So what we can tell ultimately is that the hedge has protected our position because the hedge was profitable to the tune of 810,000, which is that. This is the outcome of the hedge. This is why we set up this hedge. So what is the return of our portfolio with the hedge? With the hedge, the return of our portfolio is going to be the following. So it's going to be the end value minus beginning value divided by beginning value. So it's going to be 5,053,750 minus 5 million divided by 5 million. What does that give us? Well, we have our 5,053,750. So we're going to do minus 5,123,123, that's 5 million, equal, and we divide that by 5 million, so it's going to be 5,123,123 equal. So our return is about 0.01075. That's going to be 0.01075. That is approximately equal to 1.075%. So it is approximately equal to 1%. And so at 1% return, we know that the 1% return is about equal to the risk-free rate of return for 3 months. So we earn effectively the risk-free rate of return here. By locking this performance of our portfolio in, what we're able to do by locking essentially this price, the forward price today, we are saying that when we close out our position, we're going to make a profit on the futures contract of 810,000. Our portfolio value itself is going to drop. That's why we entered in the future anyway. It's going to drop to 4,253,750. When you put those two together, the outcome is at 5,053,750. Now, the 5,053,750 is nothing else but a return of 1% from the 5 million that we started with. So we started at 5 million. We earn 1%, which is equal to the risk-free. Now, what is the beta of a risk-free portfolio? The beta of a risk-free portfolio is equal to 0. So ultimately, we said we went from a beta of 1.5 to a beta of 0. That's what we did. By hedging, we were able to reduce the beta of our portfolio from 1.5 to 0. So we can essentially construct a generalized formula for this. And the generalized formula would be as follows. Well, if we want to reduce the beta of our portfolio, we could essentially place a hedge, a short hedge, where our hedge ratio is going to be equal to the beta that we have minus the beta that we look forward to, that's beta star, and then we're going to multiply this by the value of our portfolio divided by the value of our futures contract. I'm going to call this S. This would be the hedge ratio that you would the hedge ratio that you use in order to protect or to reduce your the beta of your portfolio from, so you go from beta to beta star, and that is reducing the beta of the portfolio. So to reduce the beta of the portfolio, you're going to take short futures with a hedge ratio that's equal to the beta that you have minus the beta that you want multiplied by the value of your portfolio divided by the value of the futures contract. Now, if we apply this here, we wanted essentially a beta of 0. We wanted to completely get rid of the beta. So we would be saying the hedge ratio would be equal to the beta of 1.5 multiplied by beta of 1.5 minus our wanted beta is 0, minus 0. And then we're going to multiply that by the value of our portfolio divided by the value of our forward. That's essentially what we would be doing. And so if we wanted a beta of say 0.5, we would be saying 0.5 here, and so on and so forth. Now, what if you wanted to increase the beta and not decrease the beta? If you wanted to increase the beta of the portfolio, what you would do is something very similar. So to increase the beta, from beta to beta star, in this case, remember we're reducing, so we're reducing here and here we're increasing. What we would find out is we would need a hedge ratio that's going to be equal to, this time I'm going to start from beta star minus beta. It's very similar to what we have, except for the fact that we are flipping the betas, multiplied by the value of our portfolio divided by the value of our futures contract. And the process is the same as what we did earlier. Alright, so let's go back to the slides and we summarize this. Well, it turns out that to hedge the risk in a portfolio, the number of contracts that you should be shorted, right? If we're hedging the risk, we're essentially trying to get rid of the risk. So we're reducing the risk from beta to beta 0 equal to 0. And we would have a hedge ratio that's equal to beta multiplied by the value, the number of contracts, not the hedge ratio. I think I said that ratio a few times. The number of contracts that we would need would be equal to the value of the asset that we are looking to hedge divided by the value of the contract. This would give us the number of contracts. And beta is essentially our hedge ratio. So I'm going to go back here. I'm going to be careful here. This shouldn't be the hedge ratio. It should be the number of contracts. And it'll be number of contract. There we go. So short futures with this number of contract, where our hedge ratio is this adjusted value. All right. So changing the beta of our position, we know how we go about changing the beta of our position. To reduce the beta, what we need is a short hedge. and our short hedge is going to be using the number of contracts that's equal to the beta that we have minus the beta that we want multiplied by the value of the asset divided by the value of the futures. If you want to increase the beta, we want to take a long hedge or place a long hedge, and our long hedge would use the number of contracts that's equal to the beta that we want minus the beta that we have multiplied by the value of the asset divided by the value of the futures. So the position that's necessary to increase the beta to 2 would essentially do just that. So it's going to be 2 minus 1.5 multiplied, because in this case we're increasing, right? Multiply the value of the asset divided by the value of the forward. And in order to reduce, we'll be doing 1.5 minus 0.75 multiply the value of the asset divided by the value of the futures. That would give us a number of contracts. Now, why would we hedge equity returns? Well, we may want to be out of the market for a while because we're anticipating negative market conditions. And so in order to avoid selling and repurchasing the securities at some point in the future and incurring all those transaction costs, what we simply want to do is just place this hedge, and that would take care of it for us. Now, suppose also that the stocks in our portfolio have an average beta of 1. So they mirror the market very, very well. But then we feel that they may have been chosen very well. So they have an average beta of 1. They've been chosen very well. We don't want to get rid of them because we did a good job picking the securities. And we also think that they're going to be outperforming the market later on. So we have a window of time when the market is going to be poor. We know that the stocks are good. When market bounces back, we're going to make good return on our investment. So the hedging that we're going to place in this case ensures that the return that we earn on that portfolio is in effect the risk-free rate of return plus any excess return on the portfolio over the market. So we lock in at the minimum the risk-free rate of return, in addition to which we may earn some sort of return. So if we go back to our notes here, our return was at least equal to the risk-free, and we had the little left above that return on the risk-free that we had. Although this is almost negligible because it's just 3 months example. All right. So what do you do in the event that the futures that are available do not protect your entire your position over the horizon that you're considering? So the idea here is essentially that you want to place a hedge for a period of say 3 years, but there are no contract that's available for the 3 years. How do you do this? Well, you might place a series of futures hedges, and so you would start with one that ends say here. So if it's a short hedge that you're placing, you're going to start with the short here, and then to close out that short, you're going to take a long here to close out that short, and then at the same time that you're taking a long, you're taking another short that's going to expire somewhere here. Then you take another long to close it, and you take another short here at the same time. Then you take a long here to close it. You take another short here to start a new one, all the way here where you take another long to close it. And so this process of taking a series of short hedges and closing them is what's referred to as a stack and roll. So it could be a series of short hedges or a series of long hedges. So the idea here is that to protect the long term, we might take a series of short-term hedged position. So we can roll futures contract forward to hedge futures exposure. That's the long-term exposure we want hedge. So initially we enter into a futures contract to hedge exposure up to a time horizon. That's this first one. We enter into a short to hedge a position for the first period. One before that, the first one closes, we start a new one. So that one's closing, we start a new one. So just before the maturity, we close them out and then replace them with a new contract, reflect the new exposure. So we close the first one, we start the second one. By the time the second one is closing, is ending, we close the second one and start the third one. By the time that closes, we close it and start the last one and end it here, and so on and so forth. Now, working with the stack and roll might be tricky because the longer the maturity that you have here, the longer the maturity of the overall hedge, the more uncertain those future prices become. Now, you remember that whenever you're working with a short hedge, what you have is at every single point here, you will have to close the position, right? So in this case, at this first point here, you would have to close the position. So you need to find out about the outcome of your contract, of this contract. So the outcome of this contract is going to be, if it is a short hedge, you are going to be receiving F1, and then you're going to be selling F2. Now, this closes out the contract, and because it's such a short edge, you're also going to receive S2. Now we show that this is equal to F1 plus the basis 2. The problem here is that at every single point, you're going to have F1 plus the basis. Here you're going to have F1 plus the basis. And here you're going to have another F1 plus the basis. Where the F1 here at this point is the first hedge, the F1 here is the second hedge, the F1 here is the third hedge, and the F1 here is the last hedge. That is a stack and roll. The problem though is that basis keeps changing too. So, right? So we start with the basis here, start with another, continue with another basis, and so on and so forth. And so there's also uncertainty with respect to the F1 here. Now, there are futures contracts, and you know that with futures contracts, we go through the exchange, and the exchange does ensure that there is no default. And the way the exchange ensures that there is no default is with margins. So, if the price on the line, it turns out, reduces or increases so much so that you're required to post margins, you may have to post over a long period of time, over the entire period of time here, you may have to post margins over this entire period. And the margins, the accumulated margins that you may have to post may create a liquidity problem. Right? Your ability to meet those margin requirements may become a problem over a period of time. And so that issue was the case at some point with a German company, and that is what your business snapshot 3.2 is all about. So I recommend you spend some time reading that business snapshot as well. And that refers to the liquidity issue. And what we're saying here is that in any hedging situation, there's of course a danger, right? That losses will be realized on the hedge while the gains on the underlying exposure are unrealized. The idea here is that we have losses on the hedge. That is going to be the differences between the F1 and F2 that we talked about, that they realize, and they realize because, well, you enter into futures contract, you have to post margins because of the daily settlement. And so that can create those liquidity problems, and the German company is that company. That's your business snapshot 3.2. So spend some time looking at that. And what they did is they placed a series of stack and roll hedges on the price of oil, and it turned out that the price of oil fell, and they had to post several margins for a long period of time. Okay, so this wraps up our discussion of Unit 3. And in this Unit 3, we talked extensively about hedging using futures, hedging strategies using futures, and we essentially talked about two types of hedging. We said we could look at short hedges or long hedges depending on what we want to do in the physical market. If we wanted to buy, we'll take a long hedge. If we want to sell, we'll take a short hedge. We looked at generalization of those. We said we could apply it to a portfolio of securities. We could also apply it to individual securities. The problem with individual securities is that they come with unsystematic risk, right? We're looking at beta, which is a measure of systematic risk, when we're talking about hedging equity portfolios. If you're doing that with firm specific of stocks, unique firms, you're not really measuring risk with beta, and so you want to be careful that there's some systematic risk or idiosyncratic risk that's still lingering around there. And we made those generalization. We talked about the adjustment that we need to make for mark to market for daily settlement. And in those adjustments, the hedge ratio needed to be corrected. And the way we corrected the hedge ratio is by using the daily correlation and the daily standard deviations. And we also talked about how we would go about changing the beta of a portfolio. And in changing the beta of portfolio, we would essentially want to take a short position if we want to decrease the beta of our portfolio, and we will want to take a long position if we want to increase the beta of our portfolio. Alright, that wraps up Unit 3. I'll see you in the next videos, and we'll start talking about Unit 4. I'll see you next time.